Hello everyone. So as promised, here is the video for exam 1 common mistakes. So one of the mistakes I saw was that a lot of people did not put equal signs for expressions. So what do I mean? Like for example, let's look at this problem. Okay, this is an expression. And so people would just put like negative 12 minus 6i plus 7i minus 14i squared. Then they would say negative 12 plus I plus 14, and then 2 plus I. Right? So you need equations, like how sentences need periods, like punctuation marks, right? Because without equations, this all means nothing. This is an expression, this one is an expression, and so on and so forth. There are just four separate expressions, but without an equation, without an inequality, right, this all means nothing. Okay, so you need to communicate with me, because is this less than? I don't know. Right, so you have to tell me that these are equal. Okay, another thing people did, I think I'll mention it later as well, but a lot of people with this expression, I think we're so used to equations that when you guys see expressions, I think you like kind of freak out, maybe, I don't know, and just like you're thinking it has to equal something. So some of you said this is equal to 0, and like all of this. Okay, and that makes absolutely no sense. Okay, so expressions, right? If there's no, it does not equal something, that's fine. It's not. It just means it's not an equation. It is an expression, and so the equal signs will come from you doing the operations and getting to your final answer. All right. Another thing is some people skipped way too much work. So, for example, I wish I could think of an example at the top of my head, but let's say, I don't know, let's say like let's say W minus, I don't know, minus 3W minus 10 is equal to 0. Okay, some people, they would skip this whole W minus 5W plus 2. Okay, some people would just go straight here and they'll tell me W is equal to 5 or 2. Right? That, you can't do that. Okay, you can't just jump from this problem and then just tell me what it equals to. Right? So I'm going to assume that you looked it up and you just put down the answer. Right? So you lost a lot of points because you did not show me how you got to your answer. Okay? A lot of people also, what they did is they would get to this, they'll say equals 0, and then they just don't put equals 0 right here, and then they'll say W is equal to 5 or negative 2. Okay? That's wrong. So the reason why does it equal 5 and negative 2 is because this whole thing is equal to 0. So I can say W minus 5 is equal to 0, or W plus 2 is equal to 0. Okay, you cannot drop this 0. Okay, if this drops to 0, it just becomes an expression, and you can't solve for W anymore because there's nothing to solve. Alright? The only thing, like, with this, if we're not given equal signs, like equal 0, then the most I can say is simplify this or factor this. Alright? So, another thing is no squiggles. It's too messy. Either one, invest in whiteout, or cross it out and start a new line. So what I mean, so some people, they just go crazy and then they'll like do this and then they might mess up, so then they squiggle and then do this. All right, no, this is not acceptable. Okay, would you turn in a paper like this? No, or I would hope not. Okay, so if you say that you made a big mistake, so say that this whole problem right here was wrong, you can just cross it out like this and just rewrite. So to say this was number 2, then just start at number 2 again and just start again. That's fine. Okay, because I understand sometimes a mistake is just too, like I understand the problem where sometimes you just realize you just did the whole problem wrong and it's not worth erasing or using all that whiteout. So just, put an X, okay, that's fine, and just start. But no squiggles. I do not want to see any of this, okay? That drives me nuts. Another thing is that people do not finish their thoughts. So what do I mean by that? So an example is with absolute values. Some people would end up like right here, okay? And then they divide by 3, but then they tell me x minus 2 is equal to 2 or x minus 2 is equal to negative 2. All right, you can't do that yet. You have to show me x minus 2 is equal to 2. All right? So if you don't do that, you just need to do that. You need to finish your thought. I understand if you know what it is and you just want to write down the answer, I understand that. That's only acceptable if you're doing scratch work. So, for example, the Alex homework, okay, you can do that because I'm not going to see your work. I'm going to be honest with you guys, when I do scratch work, I'm kind of all over the place. All right, but I do understand there's a difference between scratch work and work you have to turn into your teacher. Okay, to be honest, like sometimes, like my scratch work, I leave it for 24 hours, I come back, and sometimes I'm like, what the heck did I just do? Okay, so honestly, my scratch work is not that good because I am all over the place. However, the work I turn into my teachers, I make sure it is clean and orderly. All right? So yeah, you have to finish your thoughts. Some people didn't, so if they went from here to here, I counted off points because that's also considered skipping too much work. All right? Another thing, multiplying and grouping wrong. So some people, I put it over to the side. Okay, some people, for example, because I remember, okay, let me erase this. If we were given this, okay, maybe I shouldn't say equals 1. Is that even true? 3. Okay, but let's just say this equals 1/6x. Okay, and then I just want to get rid of my fractions, okay? I told you guys it is acceptable to do it this way, to just group the entire thing and then multiply it by 6. That is perfectly fine. However, some people, they grouped it like this but only told me 6 right here. This is considered wrong because you're just telling me, so looking at it like this, that means your equation's unbalanced. Because you only multiplied 6 on one side, you'll have to do it on the other side. Okay, the only time you can write that once is if you put parentheses around the entire equation. Right? Another thing people did, okay, is that they'll make their multiplication so small it looks like an exponent. This is also wrong. Okay? Because you cannot make it look like a power. You have to clearly show that you are multiplying. You are not taking a power to something. And I know actually a couple of you, I'm assuming you did it to multiply, but I think because, it's a test, so time crunch, and I think because you wrote it so small, you read it as a power, and so you applied it as a power. All right, so that's wrong. Okay, so yeah, don't do that. So don't group it wrong. And just make sure you group it correctly. Okay, if you want to group it like this, that's fine. Just make sure you put the 6s on both sides. All right, and then just make sure they don't look like powers. If they look like powers, I did take off points for that. All right, let's see. Oh, I guess I put not finishing thoughts twice. My bad. But that's how important it was. It's because a lot of people just, would skip a lot of steps, like not even finish, or they would start maybe w minus 2, w minus 4, and then in Alex they will put in w equals 2, 4. Right? On paper you still have to show me your steps, okay? Because you'll have to put w minus 2 equals 0 or w minus 4 is equal to 0, and then you have to solve accordingly. So w equals 2 or w equals 4. All right? Another thing is a lot of people either omitted the and or they use it incorrectly. So a lot of you, okay, you just did this. That's not right. Okay, is it or, is it and? Okay, so that's really important, and just to clarify, it's or. Right, so let's think about that, because and, remember for and, both of the solutions have to be true in order for it to be a solution. Okay, as opposed to or, it's saying my equation, for my equation, w equals 2 satisfies it, or w equals 4. So that means it's one of these two. Right, it's the union of these solutions. Okay, so yeah, a lot of you, not a lot, so a good handful though put and, okay, and then even more just omitted it. Okay, it also goes for the inequalities. You have to tell me if it's or and as well. Right, so what else is there? Okay, another one, so some of you did, a lot of you actually struggled with this one, right? Some of you divided, I don't know, it was kind of strange, but for example, you guys ended up saying like 5 over k is equal to 2x plus x, right? This is wrong, okay? And how do we know it's wrong? Because if I divided everything by k, then I'll get 5 over k is equal to 2x over k plus x. As you can see, these two do not equal. Okay, if you're going to divide by k, you have to divide every single term by k. Okay, so since a lot of people did not get this one correct, okay, I thought you guys could do it, just because we talked about some problems, like kind of harder problems, but even like factor by grouping, like 5x minus 1 plus, I don't know, x minus 1, right? It's the same concept here, okay? X plus 1, or x minus 1, they both have it in common, so I can just factor that x minus 1. Now I'm left with 5 plus x. Okay, same thing here. I wanted to solve for x, right? But I see two x's, but in order to solve something, I need only one of them. Okay, so I'm looking at it and I notice both of these terms have x's. So what do? I'm going to factor that x out. Okay, so if I check my work, if I distribute this x back in, I'll get 2x plus kx. Right, so it's the exact same as above. And then now I want to get x. Since we're solving for x, I want to get it by itself. Right, so I'm going to divide 2 plus k from both sides, and then I will get x is equal to 5 over 2 plus k. Right, and that's how you solve that problem. Right. Let's see. Another thing that I saw that was wonky. So some people did like 3w equals 9 is equal to 3. Okay, this is wrong. Okay, I knew what you guys wanted to do. This is not the same. These are not equivalent. It's not equivalent to saying 3w equals 9, which implies w is equal to 3. Right? These are not the same sayings. What you're telling me is that 3w equals 9, which equals 3. This right here is a contradiction. 9 can never equal 3. Right? So if you did this, I also counted it wrong. Okay? Because that is not a true statement. Right? Another thing, what was that kind of accent? Don't put everything under so some people don't put everything under the square root. So for example, if you're supposed to write the square root of x plus 12, some people write it as the square root of x plus 12. These two, they are also not equivalent. They are not the same. This one tells me I'm taking the square root of everything of the x plus 12. So what does that mean? I have to add x and 12 first before I take the square root. The second one means I'm going to take the square root of x and then I'm going to add 12. Right? Completely different statements. Right? So yeah, just either make sure everything is under the square root. Okay? Or if you want to do it like the calculator, because I did notice some of you do, which is like like this, okay? But one thing to take note about the calculator is that there's parentheses right after, like right there, okay? So then you could put x plus 12, okay? I'll put, maybe I'll just put even more, okay? Just to make my statement larger, okay? This is acceptable if you put these in parentheses. What this is telling me is I'm going to take the square root of everything in the parentheses. All right, because these are all grouped together. This is not my preferred way, okay? But if you just, I don't know, if you just really do not like drawing lines this long, I will accept it if you put parentheses around it. But I will not accept something like this, right? It's not the same. Okay. Another thing about, so an nth root, okay, some people, for one of the problems, they did it like this. Okay, this is not the same as saying the sixth root of a. Okay, this is telling me this is 6 times the square root of a. This is telling me this is the sixth root. You want to find the sixth root of a. Okay, so again, completely different. All right, so just make sure that the 6 or whatever number, if it's not 2, just make sure it's like kind of just tucked in to this 6. All right, just make yeah, and you do not put it like right next to it. Okay, so just kind of make this a little big and just put the number, whatever number corresponds with. All right, another problem that a lot of people did not do correctly is something that looks like this. So this example, as I took the fourth root of 3x minus 3 minus the fourth root of 2x plus 4 is equal to 0. Okay. This just, it kind of just broke my heart, not gonna lie. A lot of you, okay, I saw a lot of variations, so I'll talk about it. A lot of you, some of you did this. Okay. This is not the same. Okay. Just, yeah, no. All right. Whatever you do to one side, you have to do the other. So if you wanted to take the fourth root, okay, you would have to be all like that. Okay, doing it like this, it unbalances your equation. Okay, so yeah, some of you did that, so then you'll get like 3x minus 3, and I think then you guys did this. Okay, so coincidentally, a lot of you actually got the correct answer, but the logic to get to that correct answer was completely wrong. So you did not get full credit for that. Okay. Another thing people did, okay, so that's not good because it unbalanced your equation. But some people, so this part, a little more correct, all right? You're keeping your equation balanced, but when you guys did that, you said it was 3x minus 3 minus 2x plus 4, right? So this is wrong, right? So what does the fourth root mean? The fourth root means you take this whole thing and you multiply it 4 times. So it's going to be fourth root of 3x minus 3. So notice going back to the square root, notice since it did not reach my whole thing, I just made it longer. Okay. Alright, this is a lot, but do you guys get the picture? So, I'll copy and paste this. Then I'll have 4. Okay, so I have to make this a little smaller real fast. Okay, but as you can see, this is what the fourth root of 3x minus 3 minus the fourth root of 2x plus 4, all to the fourth power. This is what it means. Okay, this is gross. Don't want to do it. Right? So, but yeah, if you did it like this, it's also wrong. So what is the correct way to do it? If I had, let me make this bigger real fast. All right, so if I wanted to do this problem, the fourth root of 3x minus 3 minus the fourth root of 2x plus 4 is equal to 0, what I want to do first is I want to add the fourth root of 2x plus 4 to both sides. So then I'll get the fourth root of 3x minus 3 is equal to the fourth root of 2x plus 4. Now, what we can do is we can take the fourth root to both, or the fourth power to both sides. Then I'll get 3x minus 3 is equal to 2x plus 4. And then you'll get x is equal to 7. Right? Another thing for an even root, okay, don't forget there's 2 times. So you should always check your equation just to make sure things are on the right track. But the 2 things that you absolutely no ifs, ands, or buts have to check are even indexed roots and rational numbers, all right, or another way is fractions, okay, because this might be an extraneous solution, okay, so you have to check it. I'm not going to here because I'm pretty sure you guys are all familiar with checking your work, right, and I don't want to make this video longer than it should be. So this one was a doozy. So another example would be the square root of x plus 3 minus 3 is equal to x. Some of you, I do not know what happened. So some of you, I don't know, some of you did this. Okay, I was very puzzled when I saw this. You cannot do this. Okay, again, it does not make your equation balanced. And even so, when you do this, you'll get x plus 3 minus 3 is equal to x squared. These two, they are not the same. Okay, let's so let me think of an example. I don't know, I guess we can just do x equals 0, okay? If I do it over here, okay, looking at this equation, I'll get the square root of 3 minus 3 is equal to 0, okay? And then over here, we'll get 3 minus 3 is equal to 0, or 0 equals 0. Okay, as you can see, you do not get the same results, okay? No matter which equation, if they're all equivalent, when you plug it in, it should all give you the same result, okay? These do not. Okay, so yeah, that happened, all right? So yes, you can't do that, all right? Another thing, oh crap. Okay, another thing people did is, so this one, more correct, okay, you can square both sides, that's fine. However, remember this a plus b or a minus b quantity squared, it is a perfect trinomial, and what did I tell you? It is not a squared plus b squared, right? There is a middle, okay, but I think test time, some of you forgot, okay, so some of you just put x plus 3 plus 9 is equal to x squared, right? Again, that is not correct. Okay, if you had done it this way, you would have gotten x plus 3 minus 6 square root of x plus 3 plus 9 is equal to x squared. All right, if you had done it this way, then maybe some bells should have rang because you're like, this does not look any better than this first one. Okay, so again, not right. So what would we have done in this problem? We would have added 3 to both sides, so I got x plus 3, because remember, you want to isolate the square root first. Okay, same thing here. You wanted to isolate the fourth root first. Okay, and you'll do that, then you square both sides, then you'll get x plus 3 is equal to x squared plus 6x plus 9. Okay. This was also another example when people skipped way too many steps. Some people just from here to here, they would told me 0 is equal to x squared plus 5x plus 6. Right? You can't do that. You skipped way too many steps. I said, wait, hold up. And then I had to take out a piece of paper and make sure that all of your work was correct. Okay, and then I counted off because you skipped too much work. Okay, so we're almost done. Hang in there. All right, so there were quite a few mistakes that I wanted to cover. Right. So another thing was the quadratic formula. Right. So first thing, so it's multiple things. First of all, the quadratic formula is an equation. A lot of you wrote it as an expression, right? That's not right. Okay. So, but yeah, you didn't say x equals or whatever equals, like the y equals. You just gave me the other part. Okay. The other one, I guess I just didn't think about it, so it's kind of on me. But we learned the quadratic formula in the variable x. Okay, so let me just tell you about the general. So in general, I have a bar or a box squared plus b box plus c is equal to 0. Then I can just say box is equal to, and then that whole the whole expression right there on the right. Okay, so because keep in mind we are solving. Okay, what is the quadratic formula? Remember, it derives from from completing the square. But what does completing the square do? You're trying to find the zeros of x. You're trying to find the solutions. So graphically, just kind of thinking about it, because now we're talking about equations in two variables, right? If I'm saying 0 is equal to x minus 3, x plus 5, this is essentially telling me that y is equal to 0. Okay, I'm finding my roots. I'm finding pretty much the, another thing is I'm finding the x-intercepts. Okay, but when we talk about 1D, it's just about the solutions because it's just a number line, right? Okay, but you can also think about this as like an x-axis without that y. So if you were given like w squared minus 2w plus 5 is equal to 0, then your quadratic formula would be w is equal to, and then minus b plus or minus, and so on and so forth. All right. I mentioned this, sometimes people added equal 0 for no reason. It mainly happened for expressions. Or they would drop 0. So a lot of people, for the quadratic formula, again, they drop the 0. Okay, you can't use a quadratic formula, or you can't solve, or you can't even, I guess you can factor, but you can't solve for w, okay, without, if there's no equation. You can't apply the zero product property if you do not set it equal to 0. Okay, so that's really important. Don't drop it. And that a lot of, so for question 23, it was an extra credit problem, but not, I only think a couple of people got full credit because a lot of people just gave me, like I don't know, just say if the zeros were 4 and negative 5, then I can say x is minus 4, x plus 5. And then you solve it, okay, but this is not right. Okay, if I'm given zeros of 4 and negative 5, what does this imply? This implies x is equal to 4 or x is equal to negative 5. So then I can subtract 4 from both sides. So x minus 4 is equal to 0 or x plus 5 is equal to 0. Okay, so what does that mean? Then this is pretty much using the zero product property in reverse. So this is x minus 4, x plus 5 is equal to 0. And then you'll get x squared plus x minus 20 is equal to 0, right? So these are the steps of having to solve if you're given zeros and you just want to know the quadratic form, or if you want to know the quadratic equation. Okay, but it's not right. Like I counted off if you did not equal 0. Right. The last thing I want to talk about is question 24. So question 24, again, it was a extra credit problem. So if you didn't do it, that's fine. However, a lot of you did not follow the instructions. It said to complete the square. I purposely picked a problem that would give you integers. I didn't want to make your life harder by adding fractions. Okay, that's a pain in the butt. But one thing I didn't account for, okay, was that you guys wouldn't read the instructions, because a lot of you ended up factoring instead. So you did get the correct answer, but because you didn't complete the square, I didn't give you the points. So a lot of you would have gotten 2 because you factored out the problem and then you set it equal to 0. I thought that was worth 2 points. Okay, but you solving, getting the answer, I didn't give you anything just because you did not complete the square, didn't follow the instructions. All right, so that is it for the exam 1 common mistakes. I hope I got everything. Okay, I hope everything was clear. If not, if you have any questions, just let me know. Okay, so don't forget, this is an assignment. All right, so what I want you to do, okay, I'll post it on Blackboard, but I'll tell you here as well. Okay, so first of all, how many common mistakes were there? Okay, if you've been here for this long in the video, I'll just give you the answer. It is 16. Okay, why is it only 16? Because I accidentally doubled 4 and 7. Okay, so that one's given to you. The second one, I want you to tell me, okay, so what mistakes did you make on your test? Okay, so I did post on Blackboard. I gave you guys the breakdown of your questions, right? But I would still, so I would really look at the ones that you missed points on, but I would still look at your problem overall, because there were a couple of things that I just didn't think were big enough to take off for, right? But mainly look at these 16 issues and tell me what you did, right? I just want you to, the purpose of this is just to reevaluate what you did, just so you're aware of it and hopefully you don't do it for the next test. All right? Oh, sorry. One last thing, and then I will let you guys go. Okay, so a thing about and or. Some of you, right, there's this one problem. Ended up being a, what was it? Anyway, so let's say that you ended up getting something like this. Okay. But some of you, I think, you got like let's say -6 less than y, and then you said y greater than 4 or something like that. Okay, so I have -6 and 4 here. If I drew that, -6 greater than, or y greater than -6, so it'll be over here. And then I have y greater than 4, then I'll be over here. Okay. If you guys, some of you did -6 to infinity. Okay. But if you think about it, if you put and, this is wrong. Why? Because from -6 to 4, it does not satisfy both equations. If this were true, then your interval notation should have been 4 to infinity. Okay. There's also some of you who, just like sign mistakes. Okay, it happens. Okay, but you'll say, I don't know, let's go with -6 and 4 again. You'll say y is less than -6 and y is greater than 4. Okay, and then you gave me this interval and then you gave me the interval notation. That is also wrong. Why? Because it's and. It is what is in common for both equations. Right? So as you look at here, it's not common for both. So the correct answer to this one, if you had done this, it would have been the empty set. Okay, doesn't nothing, and then it would have been an empty number line. Also, when somebody For example, let me see. Let's say y is greater than negative 6, or y is greater or less than 4. Okay, some of you ended up getting the correct interval, so let's say it was like negative 6 to 4, right? However, if you use this or, then your interval was not correct. Why? Because, again, let's graph it. I have y greater than negative 6, so it looks like that, and then y less than 4, so then I go over here. Okay. So if this was an OR graph, right, remember it is the union of everything. It's wherever I see a tick mark. So if this was OR, then my correct interval would have been negative infinity to infinity. Okay. So some of you did get the correct interval, however, you did not use the correct compound word. So I took off for that because if it was this compound word, then the interval that you gave me was not correct. I know I keep saying lastly, but I keep thinking of things. One other thing, and I promise I'll be done, is some of you, when it came to absolute values, so not very many people did this, which I'm really happy about, because remember how I said in order to solve an absolute value, no matter if it's an equation or inequality, you have to get the absolute value by itself. So a lot of you subtracted, which is good. However, some of you did not isolate this, so I'm going to pick a better number. I'll say 4. Okay, some of you did not divide 2 from both sides. You just told me 2x plus 6 less than 4, and then 2x plus 6 greater than negative 4. Wait, hold on. Yeah. Okay, another way to write that would have been negative 4 less than 2x plus 6 less than 4. Okay. Yeah, that's not right. Okay, you have to isolate the absolute value first. Okay, a lot of you also did less than negative 4, right? That is also not correct because technically, so remember what is an absolute value? I'm going to take this one instead. I'll have the absolute value of x plus 3 less than 2. Right, so then remember what is an absolute value. If it's positive or minus inside, it always spits out a positive. So it's also x plus 3 less than 2, but it's also that negative x plus 3 less than 2. So if I divided, or if I divided both sides by negative 1, I get x plus 3 greater than negative 2. Right? And it also brings me to some people did it this way. They use the definition, which is perfectly fine. However, again, you did skip a little too many steps. Is some people immediately told me negative x minus 3 less than 2, for example, and they wouldn't even show this part. Okay, I did take off. The reason why is because like you just skipped it. Like it's not very clear what you did. All right, just one more thing, and I promise I will end this video. Also because I need to eat dinner. So it just goes back to the identity conditional stuff. A lot of, so for example, negative 7 plus 3x, and then you'll get like 3x minus 7. A lot of you just told me the real numbers, right? Well, however, it is true and that this is an identity, but remember I said that you have to make it like you have to just make it painfully obvious that these two are the same. Okay, I know they're the same because I understand that addition is commutative, so I could just have switched them, right? But if anybody ever looks at this, they're like, anybody out on the outside, they might not see that this is exactly the same. So you either had to tell me 3x minus 7 is equal to 3x minus 7. I accepted negative 7 equals negative 7. 3x is equal to 3x. And I would have also accepted 0 is equal to 0. Okay? So that is it. If I think of anything else, I might talk about it in class. Right? But thanks for being patient with me. Sorry, I kept adding a lot more. I will still accept this 16. Okay, don't need to make it more complicated than it should be. All right, but you all have a nice day, and I will see you next class. Bye.